All right, so we're going to take a look at the second part of law of sines. And just as a reminder of what the law of sines is, put that up. So sine of alpha over A equals sine beta over B, which is equal to sine gamma over C. At any one time, how many of those fractions do we use? Just two. Either the first two, the last two, or the first one with the last one. All right. When we're doing a law of sines problem, we learned that there's three cases. Can somebody remind me, what's one of the cases we did yesterday?
Angle, side angle.
So we did angle, side angle. And that would look something like this. Let's see. Angle, side, angle. Be a problem like that. Okay. What's another type? Yep.
Side angle, not angle side.
No. So we're going to go with side angle. We're going to talk more about that one in a minute. And then, yep.
Side angle side.
Side angle side.
Side.
No, we didn't.
Angle.
We did side angle. Yeah. Okay. Side angle would look something like, let's say this is 8, this is 100, and angle, that's 20. Side angle. The third one, side angle, you got to be careful with that one. Because we could, when we solve it, what's the most number of answers you could get? We didn't have it, but I told you you could.
Two.
You could get 2. That's the most. Or you could get, what are the other two cases?
Just one or none.
1 or none. Okay, so we looked at the case where you can get one solution. Now we're going to look at the case where you get the 2 solution and the no solution.
So the side angle one, is that side at 8?
Yeah, it could be any number, but I think I had it as an 8.
Okay.
Yeah. Okay, side angle, that's a little harder for me to draw and have it come up with these different cases. So we're just going to look at a picture. Well, we'll do a picture after. All right, let's look at this one. So we're using the same formula as yesterday, so there's no new formula. Tomorrow it's a new formula. Okay, what tells us here that this is law of sines without a picture?
2 in the same row.
2 in the same row. Okay, if I make my sketch, I've got a side, I've got the angle across from it, I've got another side, but I don't know the angle across from it, and then I've got a third side and a third angle that I don't know. What kind of triangle is that using our 3 letters? It's, side, angle. Yep. So remember, side angle, that is the one where you have to check for 2 solutions, no solution, 1 solution. Okay? 1 solution is kind of the middle case. You don't have to do as much work as a 2 solution, but it's not as fast as a no solution. A no solution is very fast. All right. Because it's side angle, you're forced to figure out something first. What's the first thing we have to try to find?
The other side. Beta.
Beta. Yep. You can't do C and you can't do gamma because they're both unknown and they're in the same row. Okay. If you have an empty row, forget about the empty row unless you can figure something out in it right away. If you're thinking, well, what about Pythagorean theorem to get C? Why not that?
There's no right angle.
Yeah, we don't know yet if this is a right angle. So you can't use Pythagorean theorem and assume it is. All right. So let's find beta first. Okay, so let's set it up. Remember, you're always going to have two fractions, sine and sine. And what could I put on the left?
Beta over 8.
Sine of beta over 8. Yep.
And then 35 over 6.
So that's the row where we didn't know something, 35 over 6. We got the whole thing. And these are the problems where you generally don't need to cross multiply. You just have to multiply by a number. What number in this case? What is it?
4.
So we're trying to get this by itself.
Oh, I don't know.
So you cross multiply it and then you have to do sine -1.
I would just multiply by a number. I would not cross multiply here.
I think I was on something.
Yeah? Yeah. We multiply both sides by 8. When you multiply by 8, that's going to cancel dividing by 8. And make sure you do it on the other side. Alright. So now you have sine beta alone. If you cross multiplied, you would have 6 next to sine beta now. Now you'd have to put the 6 back where it came from, and you'd just be doing something and then undoing it in the next step. Okay. So we got sine beta equals, and just leave the rest of it the way it is. Now, what do we have to get rid of on the left? Sine.
And you do the inverse.
Yep, we're going to take the inverse sine on both sides. What happens on the left when we do that?
Cancels.
Yeah, the inverse sine and regular sine. It's like doing +6 minus 6. They cancel each other out. And now on the right, what are we going to do with that?
Put it to work together.
Yeah, we're going to just type it in. Right? There's nothing you cancel there. Just type the whole thing in. All right, so we've got the inverse sine of 8 sine 35. Again, is it important I close it after the 5 there, or doesn't matter?
It's important.
Yeah,
It's important.
It's important. If you don't close it, you will get it wrong. And then divide by 6. Make sure we got all that typed in. Okay. So because we didn't get no solution, this problem is solvable. That is one of the answers for beta. We don't know if there's a second one yet. We need to check that.
Don't you subtract that from 180?
Yep, so let me write that down first, and then we'll do that. So 49.886. Now, what did we just say? Subtract that from what?
180.
Yep, so if you do 180 minus, and that's the last thing you had on the calculator, you can just press second and press the negative sign, and it'll automatically fill it in for you. Okay, so my second answer, if it works, is 130.114. I'm going to put that off to the side until I know whether or not it actually works. Okay. How do we figure out if that answer is going to work?
If you can add it to the other angle and it fits in the triangle.
Yep, what's the other angle we have to add it to?
35.
The 35. If you add up 130 and 35, how much do you get?
165.
165. Is that under 180?
Yes.
Yes.
So it works.
So it works. Okay, so because the second answer plus the one we were given is under 180, you need to write the second answer down. So what we're going to do, we'll call the first answer beta 1. We're going to call the second answer beta 2. Now, if we got 2 answers in this box, what does that mean?
There's going to be 2 answers on the rest of them.
It's going to be 2 answers for everything we need to find. So this problem on a test would be worth 6 answers. It'd be worth 6 answers. And you can get partial credit for each one we get right and wrong. All right, so what are the two problems we're solving? Well, first of all, the A, the B, and the alpha. Those are in both problems we're doing. So let's kind of color code it. Alpha is in that problem, beta 1 is in the same problem, and gamma 1. Those three angles are in the same triangle. Alpha is in the other problem we're going to solve. Beta 2 is part of the other problem, and so is gamma 2. So the three blue dots are the angles in one problem. The three red dots are the angles in the other one. Yes?
I'm kind of confused. Where did you get the second answer?
We subtracted it from 180.
We took our first answer and subtracted it from 180. Yep. And now you could do the same thing for the sides. Okay, if you want to kind of visualize what sides are part of which problem. A is part of the first problem. B is part of the first problem. And C1 is part of the first problem. What sides are part of the second problem? What are my three sides in the second problem?
A, B, and C2.
Yep, A is part of the second problem. B is in the second problem.
C.
And C2. Okay, so that's just kind of color coding which piece of information goes with which problem. All right. So now what I would do is finish up your angles. Okay. What two angles are we going to add up and subtract from 180 to get gamma 1?
The 35, 49.
Yep, the 35 and the 49. So let's take 180. If you want to subtract them like this works fine too. Subtract the 35 and then subtract the 49. And that's which angle?
V, gamma 1.
Gamma 1, 95, 114. Good. All right, and which angles are we going to add up and subtract from 180 to get gamma 2?
35, 130.
Yeah. And 35 and 130 add up to?
165.
165, 114. And that gives you 14.886. If you did this step and you got a negative answer right here, then that means you included the second answer and you shouldn't have. It didn't work, right? But we already figured out that it works, and we did not get a negative answer, so that's good. Yep.
I don't understand, like, I understand, like, how to get the second answer and whatever, but, like, why? Like, where does, like, I get you subtract it from 180, but, I don't know. It seems like, I just don't get it.
Like how that could happen, like
Yeah, but, like, why?
I'll draw it out after and show you how it can happen. I'll draw something
Okay.
and show you. Yeah. All right, so let's look at C1 and C2. Both C1 and C2 are partial rows now. What row do you think we're going to use to do both C1 and C2?
A.
Yeah, you're going to use A. To do C1, you need a blue row that is full. Well, that's row A. To do C2, you need a red row that's full. That's also A. A is in both. So let's set this up for C1. So we just said we're going to use A. So sine 35 over 6 equals. And what's going to go on the other side if we're going to get C1?
95.114
Yep.
C.
4 over what goes in the bottom?
C. C1.
C1. Okay. Now let's set it up for C2. Okay. To find C2, it's going to be pretty much the same thing on the left side. It's exactly the same thing. sine 35 over 6 equals, and what angle are we going to use?
14.886.
Sine 14.886, kind of ran out of space,
C2.
over C2. It's 14.886. All right, so we're going to cross multiply on both, and that will get C1 by itself. All right, so what am I going to type in when I do C1?
6 sine 95.114 divided by the sine of 35. Or sine 35.
Sine 35, and that gives me 10.419. Okay, don't put a degree symbol on that because it's not an angle, it's a sine. Okay, and Logan, can you tell me what I'm going to type in for C2?
C2 sine 35 divided by 6.
Say it one more time.
Sine 35 divided by 6.
Well, we got to cross multiply that proportion like we did the first one.
Alright, so then sine 35 times 2.
So it's going to be, we got to start with 6 times something.
Sine 14.
14.886. Yeah.
And then sine 35 times sine 35.
Yep, so you're going to cross multiply, and then what about when you get C2 by itself?
Maybe
So like what we typed in when we got C1 by itself up above, I want to do the same thing now except for C2.
So I don't know where to start for that because I don't see cross multiply. What do you do after that?
All right, so what do we do after we cross multiply? You cross multiply, and you'd have 6 sine 14 equals C2 sine 35.
And then we divide it.
But you have to divide by the sine 35 to put that in the bottom. Yeah. So that's going to give you 2.687. Okay, and that's a two-solution problem. Okay, so with a two-solution, I don't think it's a harder problem, it's a longer problem. You have to do the same thing twice.
Is this all we're doing today?
The two-solution, the no-solution, and the word problem.
Oh.
Word problem?
Word problem.
Yeah.
Word problem. What is the word problem?
Can we not do the word problem in the homework though?
I think there is one.
I think that we should
Take it off? Can you give us one more of another one?
What if I slide you a crisp $2?
What the?
I don't think I can do it.
I got a penny.
All right, so let's look at how can that happen? Like why if I give you a side, and an angle, can you end up with two solutions? So I'm going to draw to scale. I need that smaller though. There we go. I'm going to draw to scale how you can get two solutions. First thing I'm going to do is take that side and make a copy. Does everybody agree so far that that side is the same as that side?
Yes.
So they have a side in common. Okay, next thing I'm going to do, I'm going to take this side, I'm going to make a copy of it, and I'm going to flip it. When I flip it, does that change the length of it? No. So then we agree this side is still exactly the same length as that side. Okay. So now I've drawn two shapes that have two sides exactly the same length. Now the third side, I don't have any options. Just going to connect the third side. Where's the angle that's the same?
The bottom
The
right.
bottom right, or bottom left?
Bottom left. Two angles in the bottom left are exactly the same. So this angle is exactly the same as that angle. So both of these shapes have two sides the same, one angle the same, but they look different. So this would be like your first solution, this would be your second solution. There's no other way to do what I just did with any other type of problem. It's impossible. Side-side angle is the only one that it could happen with. And that's how it could happen.
That's unfortunate.
Yeah. Okay, any question on that? All right, let's try this one. All right, so Brett, looking at that table, what does it tell us?
A's 2. And we're gonna do side, side.
Okay, so how about like the placement of the information? What does that tell us? Like where the stuff is.
Oh, then we're gonna use the property of science.
Okay, well, how do you know looking at that table that we use the law of science? Yeah. What about that table kind of tells you law of science?
It's only about the angles, but I don't know.
It's more about the placement. Yeah?
Because it's a full row.
Right, we have a full row. Anytime you have a full row, it is law of science. Okay. Also, you have no choice about what you're going to find first. What do we have to find first?
B.
No, isn't it?
Alpha?
I can't remember what the symbol's called.
Is B in a row that has something in it?
It's like
No.
the butterfly symbol.
No, the alpha.
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 Yeah.
Alpha.
That's alpha.
What is the butterfly symbol? The B.
I can't remember what it's called.
So for now, we're going to forget about B and beta because we can't find anything.
Why do we make alpha?
Because it's in a row that has some information.
I got it. Now finish the row.
Okay. So what are we going to write down now?
Sine 50 over C.
And let's see.
1. Oops.
Yep. So sine 50 over 1.
I thought you said you had property.
Oh, yes, it's fine. Sine alpha.
Yeah, we need more.
Sine something, sine alpha, sine
Equals
alpha.
Sigma, alpha.
sine alpha over 2.
Sigma.
Good. Sine alpha over 2. Now, this is the type of situation that comes up. I would not cross multiply. You just need to multiply both sides by a number.
2.
2.
Well,
Yep. Just multiply by 2, because that'll cancel dividing by 2.
And then you do it by the inverse.
Yep. So yeah, multiply both sides by 2, and then take the inverse sign on each side. Do we cancel anything on the left?
The signs.
You would not do it.
Wait, the left?
So do we cancel? Brett, do we cancel? No. Do we cancel anything on the left?
No.
No.
Already canceled it out.
Right. We don't. Nothing cancels on the left. If you're thinking sine and inverse sine cancel, no, because you're doubling it.
And then you put that in the calculator.
We got to just put that in the calculator.
Yeah.
Okay. On the right, it's gone. Okay. Now, when we looked at graphing last week, when you graph sine, what's the highest that it goes?
1.
Yeah, and the lowest?
-1.
Negative 1. Okay, so
I know better.
keep that in mind because we're gonna make a connection in a
Does that
second.
say sine -4?
-1.
Sine negative 1.
It's the inverse.
Yeah, I just can't see that far.
Natalie, get glasses.
I don't, I'm not far sight or near sight.
Okay, so inverse sine of 2 sine 50. Do I need to close the 50?
Yes.
Yes.
Yes,
Yes.
you do. Yes, you do.
And then we're just dividing by 1.
That's fine.
We don't really need to divide by 1, but we can put it in.
Might as well.
Okay.
You needed to close.
So when I hit enter,
That means we can't have any solutions.
No solution.
so yeah, when we hit enter, we got
Can we get more
a
of these calls?
domain error. Well, forget about the inverse sine for a second. Let's just do this.
Why would you have no solutions?
We're going to draw that in a second. I'll show you. 2 sine 50 came out to how much?
Is it not a triangle?
It's an unsolvable triangle.
Or it's not a triangle?
Yeah, it came out to 1.5. If you draw, let me put this like this. If you draw a sine and you put a line at, let's put in sine, and then put a line with that number I think was about 1.5.
Yes. Oh, is it
Where,
it doesn't
where
touch
does
it?
the line and the wave cross?
Not in the middle. Wait, what line?
Is it
The red
never
line.
because the line is higher than it goes?
Do they cross?
No.
No. So by trying to do the inverse sine of this number, you're trying to figure out where those cross and they don't. So that means there is no solution.
I see. Very insightful.
So now, what we would normally do is take that angle, add it to the one we were given, and subtract from 180. But why can't we add the 2 angles and subtract from 180?
Because there's
No
no
solution.
angles.
Right, because we don't know that one. So if we don't know that one, we
What
can't
does
find that
triangle
one.
look like?
So this be not even a real triangle?
Would it be
Yeah.
like with a gap?
How about B though?
No solution.
Right, if you can't find the angle, you can't find the side across from it.
So isn't this just a line?
Well, let's draw it and see what it looks like.
Yeah.
Okay, because we do have 3 pieces of information.
Is that an angle?
Okay, we have one side that's 2 units long, and we have another side that's 1 unit long. Doesn't matter what you use for 1 unit. Like if you use inches, centimeters, it doesn't matter.
Miles?
Nope, doesn't matter. You just need one side twice as long as the other side.
Okay.
So here's one side, and now I need a side twice as long.
So 2?
So I'm going to put 2 of them together. Yep. So that's 1, that's 2. Now, I need to be able to rotate it, but I need to be able to do that for this one too. Notice it doesn't have the green handle because it's not grouped with anything. So what I can do is just group it with anything. And then I can erase what I grouped it with. And now it's got the green handle. So now I can turn it. Just the way it works.
Can you just move the picture over just so I can see how you think?
Yep.
I was just out of the room, so I didn't see how you set it up.
Okay, so now what side is 2 units?
2 units?
Yeah, what side is 2 units long?
A. A is 2 units.
So A, question? So A is 2 units, and A has to be turned so it's at about a 50-degree angle, because that's where it goes in the triangle. So that's pretty good. So that's A. So there's 2 things now. I cannot change the length of that, and I can't turn that. It has to stay at 50 degrees, or I'm going to mess up this angle. Okay, now B, we weren't given that one, but C we were given. C is 1 unit.
Yep.
C would be somewhere on the 3rd side. We can make any angle we want with it. Okay, we can put it like that. We can turn it like that.
Why can it be anything?
Because we weren't given this angle over here. This would be beta. We weren't, if I draw, let me just kind of draw something in. Alpha would be over here. Beta would be up here. And we weren't given beta. So you can make beta whatever you want. So that means this side, you can turn it. You can't change the length of it, but you can pivot it. Right? And the 3rd side. The 3rd side is the one on the bottom. That's B. Were we given B?
1. No.
We were not given B.
So pretty much it's 2 lines?
So B you can make as long or short as you want.
Oh, so it just has a gap.
Yeah. So no matter, the only things you're allowed to do is you can make this longer or shorter, but you gotta keep it right there, but you can make it shorter. Or you can take this side and turn it.
Why can't we change the angle of that one?
Because that was 50 and that was given.
Oh, okay.
Okay, you can't change that 50. You can't change the length of this, and you can't change the length of that. With those limitations, you can't connect it.
That's just
How
fascinating.
moving?
Okay, the best you can do is you can kind of shorten this
It
side,
really makes me change my perspective on that.
Change my perspective on
Yeah.
triangles.
but it's still, it's never gonna connect.
I see.
And that is 50, that's drawn to scale. That's actually a real exact 50. Okay, so any question on the no solution?
Can we get more of those?
Yeah, you will have homework, yes.
Is there any like that on the test?
Dude, you just do the first part and it says yes or no.
Well, we'll have one of these types of questions on the test, and it'll either be a no, a 2, or a 1
Wait,
solution.
so once you type.
They're kind of time consuming, so I'm not gonna probably do more than one of them.
So it's probably gonna be a 2 solution, knowing you.
Could be 1, 2,
Yeah.
or none.
Once you typed it into the calculator, how did you know that?
Because it said.
Well, it came up when I typed it in. If I go back to what I typed in, it said error.
Okay.
It's because you're trying to take the inverse sign of something that's not between -1 and 1. Yeah, it never touches.
Okay, so if it says error, you just know there's no solution.
Yes.
Is that all we would have to write on a test, is just write no solution?
Hold on. What?
What?
Question?
No.
Okay, please be quiet for me.
Is
On a
that
test,
all we-
sorry, I didn't. I
Is
wasn't.
that all we have to write on a test, is no solution?
If it's a no solution problem, yeah, I just have you write no solution. I'll probably just have you write it one time. Yeah, no solution.
Sounds good.
Okay, so any question on 2 solution, or that was the 2 solution, that was the no solution. Okay, so now let's try this one. Okay, so the last 2 questions we look at, these will be the word problems. Generally, in a word problem, we're measuring like the distance to something or the height of something, and because it's a real world object or distance, there are not 2 solutions. Okay, so that's one thing you can generally count on in a word problem. It will not be 2 solutions. Okay. All right, so what we're going to do in this problem is a surveyor is going to measure the height of a mountain. And the way we're going to measure it is we're going to take 2 different readings. What we're doing, if you've ever heard of like triangulation,
Is that with like the stick?
Yeah.
And they look through the stick?
and you can
And
look
then
through.
they know how tall it is?
Yeah.
Oh, I'm smart.
So the idea is you stand in one spot,
With a little box.
take a measurement, and then you go stand in a different spot, a little further away, and you take the measurement again. If you take the 2 measurements, then you can figure out the height of the object in front of you. So this particular problem, the surveyor is going to take 2 sightings. So they'll stand somewhere, and then they're going to back up 900 meters and take a sighting again. When they take a sighting, what they are going to measure is the angle to the peak of the mountain. So how would they do that? Well, if you had a tripod and it had like a laser or like a sight on it, you just look through it, you tilt it, and you focus it right on the top of what you're trying to measure the height of. And each time you do that, the device will tell you what angle it's tilted at. So the first time the surveyor does it, they get an angle of 47 degrees, and that's pointing the device right at the peak of the mountain. Now, when they back away and they're further from the mountain, what's going to happen to this angle?
It's going to be bigger.
It's gonna be smaller.
It's going to be smaller.
Oh, so this
Okay.
is like angle side, angle.
So it's kind of like if you were sitting on the floor in front of the screen. If you were right next
I
to
get
it,
I get it.
you'd be looking up very steep.
Wait, but that's when you're closer. When you're farther away,
And when you're farther away, it's less steep. Yeah, when you're closer, you'd have to look almost straight up. When you move away, you wouldn't have to look almost straight up because you're further away.
the space is bigger is what
Yeah.
I'm thinking.
So the second time, the angle is going to be a little bit smaller, and it's 35 degrees. Now, what would complicate it a little bit is the transit is usually on a tripod.
What's
It's
a
like
transit?
That's the device they look through on.
Oh, the stick.
Yeah. So if the transit is like 5 or 6 feet off the ground, you technically have to add the height of the transit in when you do the problem to the height of what you find.
So,
But we're going to assume that the transit
it's
is on the ground. Okay? That just makes it a little simpler. So assume the transit is on the ground. And for the height of the mountain, it doesn't, I mean, it's only going to affect it by 5 feet or 6 feet. So it's close enough. All right, a lot of description there.
so don't we just use the 3 numbers they give us?
So yeah, what do you think we want to do?
90.
First should we highlight?
900.
This is side angle, right?
No, this is the angle.
It could be.
side.
That's a few steps down the road to figure that out.
Angle,
But what do you think we want to do first?
Highlight the numbers.
Okay, so we could highlight some numbers.
Yeah.
What's some important pieces of
900.
information? That's important somewhere.
35.
The 47 is important.
35.
And the 35. Okay, yeah, so all of those are important.
Should we make a triangle?
So yeah, what do you think we want to do now?
Draw
We
a
want
mountain.
to draw. Yep, I'm going to draw this situation.
We draw the
That's what I
mountain.
said.
It's going to be a mountain.
What are the important objects in the picture?
The transit.
Okay, so we'll put the 2 spots that the person stands. Yeah,
The distance.
And the mountain.
the mountain, that's important. Yeah, that's something we're going to label.
The person.
So yeah, that's where the transit is.
Elevation.
So where the person stands, the
ground.
mountain, and the ground.
Yeah. Oh, I'm good.
So let's start with the ground.
Let's go.
Okay, we got the ground.
Okay, so there's our ground.
Where's the mountain at?
The mountain, we're going to put that over here.
It's a tiny mountain.
Yeah, what? It's a little
Why
mountain.
is it so big?
That's our
It's
mountain.
such a little mountain.
Now the surveyor is going to stand at 2 different points. Here,
I'm probably pretty sure. I don't know.
and then we'll say the surveyor stands over there.
Oh, I see the triangle now.
Where's,
The tip of the mountain.
what's the distance between the 2 spots the surveyor stands?
900.
So we know that that's 900 from there to there. And each time the surveyor, remember, they're going to point
To
their
the tip of the mountain.
tool that they're using right at the tip of the mountain.
Small.
And then they do it again.
Wow.
What's the angle that they get the first time?
45.
40, was it 45?
47.
47.
47.
So I wrote the whole thing.
What's the angle the second time?
35.
35.
Hey, now you got the right
You're in
number.
the inside triangle.
Okay, now what is it they want us to find?
Wait, I have a question.
Yeah.
You know how like in geometry we learn that like the angle has to add up to 180, so like you would just subtract 180 from 47 to get the inside of the angle?
We're gonna have to do that.
Okay.
Yeah. Yep,
Yeah,
well, we're
so-
gonna need that. But first, what is it that they want us to find?
They want us to find
height.
The height.
of the mountain.
So is this the height of the mountain?
No.
No. How about that?
No.
Yeah, no.
No, that's slanted.
How do you
Right down the middle.
You gotta do the thing where you like.
Yeah,
Yeah.
this is the height of the mountain.
How do we?
That's what we need to figure out.
1, 2, 3, 4, 5 triangles?
So if we look at this triangle right here,
Yeah.
okay, that's a right triangle.
Yes, it is.
Let's just move it. Let's move it down
Oh,
here.
we can find the
What do we know in that purple
It's
triangle?
47. There's one of the angles is 47 degrees.
One of them's 90.
And then one of them is
Wait,
90, so you
47
can add that up and
minus
subtract it from 180.
And then you do the never mind.
So we could, yeah, you could get this third angle. We don't need it, but you could get it if you wanted, but we don't need it. We need the height. This side is the height of the mountain. Do we know any sides in this triangle?
No.
No. And we have to forget about the purple triangle for now. Okay?
Oh.
Until you have a side,
This is terrible.
you can't use it. All right? So we're going to look at a different triangle. Let's see if we can focus on
That's 900.
this one.
We know one side.
Does the blue one and the purple one have anything in common?
You can smush them together and make a big one.
Yeah, they share the hypotenuse with the purple one.
They share a side right there.
Yeah.
So the goal now is we want to find the height of the mountain.
And the side.
We can't find the height right away.
But you can find the side.
We
and
need to
then
figure,
share it,
yes, we need to figure out the side that they share first.
which is
Huzzah.
every one.
Okay? So let's start working with the blue one.
Okay.
Okay. What do we know about the blue one?
35
blue.
in the corner.
The bottom is 900.
Bottom is 900,
35 angle.
it's 35.
And then if you
133.
you subtract.
The other one is how much?
133.
Right, if we subtract from 180, we get that. Now we have angle, side,
And then you
angle.
can find the third angle.
12.
Okay, is ASA one of the problems we studied?
Angle, side angle, yeah.
Yeah, it is. Okay, but to do it, you need to know the angle and you need to know a side across from it. Right now, we don't have that. We don't have a full row. But what could we find that would give us a
You
full
You can
row?
find the other angle.
We can figure out that and we need that.
12.
And it's like treasure.
Is it 12? I don't know if it's 12. And we'll done with
So 133,
it. It's not.
133 and 35 gives us, what is that, 168? And that means the third angle would be 12.
Yay!
Yep. Okay, now we have an angle and we have the side across from it. We can use law of sines. What is it we want to figure out in the blue triangle?
The hypotenuse. The-
Well, there's no 90, so there's no hypotenuse.
Wait.
What in the blue, just forget about the purple. Describe to me which blue side you're going
The
to find.
side across from 35.
The side across from 35. We'll call it X.
Huzzah.
Right?
How do you know which one's alpha when they all have things?
It doesn't matter what you call what. As long as you do sine of an angle, divide by what's across from it. Sine of an angle, divide by what's across from it.
I get it now.
So what angle do I definitely need to use?
35.
35.
Yep.
And 12.
Sine 35 over what?
X.
X. That's the row that was partially full. Now, what about the row that's completely full?
I'm going to use sine 12 over 900.
Sine 12 over 900.
And then you cross multiply.
Yep, and remember, that's not the height. That's not H, that's X. But yeah, we're going to cross multiply. Okay, what are we going to type in?
900 sine 35 divided by the sine of 12.
Divided by sine 12. So X is 2,482 point, we'll go 88.
Wow.
So
Okay.
2482.88.
Oh, so that's the side. So
Okay.
now we can do side angle.
So now we know that side, which is the same as that side. Now you got enough information, you can find the height. Okay, what kind of triangle is the one on the right?
A right triangle.
It's a right triangle, so you don't need law of sines to finish this.
Pythagorean theorem.
Well, to use Pythagorean theorem,
We
you
need
need
two
two
sides.
sides.
We only
Well,
have
we'll
one.
have two sides soon, right?
Is that?
Well, we're going to have the final answer soon.
Oh, okay.
But we-
Can you do angle side angle on that too?
So you could use law of sines again. It's a little more complicated than we need though, because it's just a right triangle.
Cosine.
What position is this side
Cosine what?
Opposite?
from the
That's
47?
opposite.
Opposite. What position is this side?
Adjacent.
Adjacent.
Hypotenuse.
Hypotenuse.
It's across from the 90.
No.
So it's what?
Hypotenuse.
It's the hypotenuse.
Okay, guys, good job.
Okay, so what trig function has opposite and hypotenuse? Your choices are
Opposite
sine,
over
cosine, or
hypotenuse.
tangent.
Opposite over hypotenuse, right?
What's that?
We know sine.
Sine, yes. So sine of
Sine of
47.
47.
47 equals,
Opposite over hypotenuse.
H over
20,
248.
7, 12, 32.
82.
and now what's your last step to get h by itself?
Multiply.
Multiply. Yep.
Multiply both sides.
So I still have that typed in, so I can just press 248288
And then times sine 47.
times sine 47.
Good job, guys.
So the height of the mountain is about 1,815.86.
Can we do this at the school? Can we do this to Wachusett?
No.
Can we do it from here too?
Can you do it as a team on the test?
And that was meters. What's that?
Can you do it as a team on the test?
A team?
Everybody just
I think we
participates a little bit.
collectively failed.
Like we just did.
What if we have all of our
Guys, you know we don't have word
Like,
problems on
If
the
it's a test is
test.
10 questions, we got 10 questions for each person.
10 different
What?
questions?
Right.
Not these ones.
It's all cool, bro. No, I don't wanna do that.
No, not like, but not.
All right,
actual
so that's-
words,
Text is
but actual
one word problem, we all
on
do
the
together.
test.
That's the height of the mountain.
Height of the mountain has been found.
Yep. So when you have a word problem, it is possible you have to find one other side first, and then you can find the side you
I
want.
see now.
Okay. Sometimes you can find what they want you to find right away, and you
I
don't
see.
have to do that. Depends on what they want to know. Okay.
Mr. Hager,
Yeah.
I've ever told you you're my favorite teacher.
You have, yeah, several times. Thank you.
Yes.
Is one of these going to be on the test? Like a word problem?
If there is a word problem, I would say at most you would have one.
Okay, great.
Mr. Hager, you're
So
gonna be,
none.
At most one.
are you gonna be in this state for April vacation?
Less than or equal to
Oh
one.
my god, guys, can we just finish this?
So salty.
Like, please.
It's what they do with the.
Was that the last one?
Yeah. Okay, so those are the three cases. You got the two solution, the no solution, the one solution, we've done them all, and word problem. Okay, tomorrow, we're gonna take a look at the law of cosines. And we're gonna start and finish it tomorrow, because there's not as much to that.
Can we triangulate your height?
You could, yes, you could.
Can we do that?
You need
for our
accurate,
test?
on the test?
As a group, that could be the test.
Oh, there's a test, we'll see.
As a group?
We'll see.
I like this idea.
So for 267, it's 29 to 35 odd, and 39 and 40.
This is.
And those are the word problems, aren't they?
I think
What is
39
the-
and 43 are the
This
word
is like
problems.
4 point what?
Okay.
4.2,
Yeah, no,
Part
it
two?
is. Yeah.
part 2.
Yeah, because